data, right? So the as a background activity, what I will tell now, like today everything is surrounded by the data, right? So it could be flat file, it could be CSV or spreadsheets or DBs, Oracle DB, NoSQL, images, audio, video, big data. So everything is data. Okay. So here the computing power of the like technology around, it could be big data or latest computing power and all, right? Shilpa madam, can you please mute that set? Seems it is having some noise in between, so that if at all anybody is able to like wanted to ask that time you can. Yeah. Yeah. Okay, it's good. um, yeah, coming back to data sources, like there are wide variety of the data sources, and there people want to get some insights from the data. So uh, some whenever we are seeing this data, like we are having this data, like we need to get something out of that, right? Today you are going to college on particular day on to attend particular session. Somebody is sending you message, okay, today we have session at 10 a.m. and we are going to have it. Then what is the you are taking a decision, okay, this particular class session or lecture session is about the neural networks. Somebody is already good at neural networks, somebody doesn't even want neural networks, so they will take a decision based on the data. Okay, maybe your college correspondent or college authority, somebody will send you through email or somebody, and you will understand whether to take a decision, go or not go. Even if you are going, so you should be prepared with something. So generally that kind of sense you'll get. So when you are going to a some from your residence or from your home to some theater or some playground or something, whether to go which route, whether to go to which route, right? So that one, what you call, wait, somebody is pinging to join. Okay. Okay. So so this data is the actual source of the decision. Okay, if you are going to playground, okay, which route you should go, the maps.google.com or other other apps, right? They are picking that availability of the which route is best, which route is not, right? So these are actually decision making is based on the data. Like first of all, how far it is, the distance, how far it is, and from there how uh, quick you can go. One is the distance and other the time. Based on that these two factors, we are able to get the we are able to take the decision to move to that direction, right? So in a way, whether you are going to rain or not going to rain, or whether to buy this or not, or whether which is selling, like if some company, like very big companies, they want to take some decision, they want to launch a product, so everywhere is a decision. Okay, so the decision depending upon the data. So whatever the past data or current data, whatever the social media, or it could be from any form of the data. Even government policies are driven by the government policies are driven by the data source. Okay, whatever the data, okay, today they want to launch some policy, some scheme, new scheme, so they will depend upon the some data. Okay, so without data, they can't take in. Of course, sometimes some decisions are, maybe if they have some self interest, that is we can't say anything, but generally if somebody has to go with proper understanding of some scheme launching, some policy making something, right? So anywhere, even if you want to buy something or sell something, everything is depending upon the data. So this data is having many forms. Okay, it is not limited to some. So and they need quite correct decision in order to take that one. In that process only the statistics have been developed, the subject statistics have been developed. After that, a machine learning algorithm has come. Actually, machine learning algorithm is part of statistics only. Okay, statistics is a very wide variety of the subject. okay, and a wide range of subject it is. So in that, this field is one thing, and then machine learning has come, then deep learning has come, then uh, like what to call the latest generative AI come, all these things. So particularly this images and particular different kind of data we are trying to solve, right? So there is a in the process after machine learning algorithm, this deep learning. Deep learning is nothing but the neural network, artificial neural network. So that is the core of our subject today, like whatever we are discussing. Okay, okay, when we are taking this neural network as a topic here in the 1960s around, there is a inspiration how to take from here, how to take from what you call from where to where, how to go, right? So this one, uh, they have taken the inspiration from the neurons which we have in our brain. Actually, how brain is processing particular data, how it is taking the input, how it is coming as output, and how it is a what you call how it is being processed. So can you imagine our brain has thousand billions of the neurons internally, thousand billions, it is not one or two. Okay, that big, like that big network is consist of our, like our brain consists that big network, and there whichever the information you are giving it, and it will try to decide which tone, whether you are like you are recognizing the image internally, those many neurons will have that replica of the memory storage and all. So this was the evolution in the evolution process, in the science evolution process, right? How brain works, how the neural, what is that when you see any brain image, right, you will have some meat, something like that, it is fluffy or some kind of meat, right? So from where that meat, actually what is inside, somebody will dissect and see and all, right? Some that is the evolution of the science. In that process they got to know, okay, this is how the brain is processing. So somebody scientist who are working in the statistics or mathematics and all, why don't we implement this kind of replica using our day-to-day activity? Like we will take the similar way some input as this part, and then we will convert. So we will take the input and we will take the will consider that neuron is the one thing, and this whatever, right? So that they inspired everything from the biological neural net, how our brain is functioning, the whatever the neurons itself. That's why this neural network is formed based on the what you call you can call it as a background is our brain only, it is nothing somewhere else, they did not bring this idea, and over the time this has been evolved and evolved, and it has become the, like with the latest computing power also. Till 90s or 2000 the computing was power was not too high, like we had very less memory. I think you are a younger generation, and I think you might not have seen certain items or certain devices in the market like floppy disk, and prior to that they used to store in even 1 MB memory also, they used to have very big machine. Okay, so even we did not see in our generation, we were last, I think we were last to see the floppy disks and all. After that so many other even compact discs, whatever the CDs we used to call CD DVD were introduced during our engineering time and all. Okay, and that and CD and DVD also gone out. I think now everybody is using memory card, or I think nobody is actually using the memory also, I guess, because everybody is using from the cloud, right? Whatever the cloud source, we are connecting through some app and we are storing all the data in the cloud, like the Google cloud or some AWS cloud or somewhere, right? So we are even that also. Whoever want to store, they want their own personal hard disk and all. They're keeping some data with them. Otherwise, everything is being stored in the there. Okay, that is altogether different, again different league of the story. But prior to this, like we where we are in the neural network, right? Neural network clearly inspired from the whatever how our brain functioning, how it is the memory is storing, how it is processing, and how it is giving the output. So that is the basic of the artificial neural network. Okay, so this is generally inputs and outputs and all. Okay, this we need not like generally what is we need not really remember all these things, but yeah, just giving the more understanding here. Okay, I think somewhere I missed this this collection, this axon, and this is wrong actually. Maybe I misquoted. I will correct it in the while I will share these slides. Okay. Okay. Dendrites inputs are correct. This cell nucleus correct, but this is just swapped. Okay. Okay. No problem. Okay. So in case of the neural networks, what we see is that the neurons, layers, weights and biases, activation functions, these are the general keywords in order to go in this neural. Like neural networks doesn't stop only with the whatever we are speaking, only this part. Okay, this part. It gone beyond that. And there different kind of networks have been developed. Some wanted to remember some like how you want to propagate from starting like input node to output node, how the memory is stored, how to remember for long time. See this recurrent this is not the topic today, recurrent neural networks and other long short term and below, these are the little advanced subjects. But prior to this, whatever is happening with the basic neural networks we will learn in detail. Okay, and then we'll go to the convolutional neural network also. Okay. Okay, so so this is another word for the basic neural network. Okay, this a perceptron is the word. Okay, so perceptron is the word. I don't think this something else. Perceptron is some other electronic word or something. It is not. It is again the word actually started with the perceptron. In the perceptron, whatever this input x1 and x2, you want to add something. Okay, and you try to add some weight to it, and then you give the output. It is a very basic form of the neural network. Okay, it is called also called single layer neural network. So you have some input like you want to add something like what you call today you need to take some decision, like x1 is the one thing and x2 is the another one. Okay, uh, you daily do some activities like today you are going to college, and going to college is the x1 and going to playground is the x2. Okay, and in that case you try to add some weight to the going to college, and no weight to the playground. Or sometimes, okay, you are going to playground off, or you going to college off, so point 0.5 point 0.5. So that is how, see, whatever the activities you are doing, whatever the decision you are doing, like how much you are spending, like if you want to spend for something, like generally you want to buy a like your school uniform or college uniform, then or you want to buy some your personal costumes, like wherever you want to attend some marriage function or other function. So how much you are giving some weight to that? Okay, I will buy college uniform some 2000 rupees or 1000 rupees. I will buy my personal costume for going to attend other function, maybe more weight you try to give, right? So like that, any of the decisions are driven by the some what you call some weight towards it. So whichever the feature or whichever the activity you are trying to pick, that you will try to add some weight. So I'm trying to simplify the weight. Okay, so this neuron, output of the neuron is always, the output will be this input and along with the weight. Without weight, you simply, if you add whatever x1 plus x2 plus x3 or x4 and all, right, that will have its own simple summation or something will come. It cannot be summation also. Sometimes it may give some other operation, like sometimes XOR you will do, sometimes AND operation you will do, or whichever the logical gates are all applicable here. But for the simplicity, for the sake of understanding purpose, we are taking this as a x1, x2 and all. Okay, so W1 is a weight. So sometimes if we are not getting the desired output, we'll try to add some bias. Okay, that is called bias. So try to understand in any single layered neural network, this is starting how neurons in the brain also getting processed. Here also we are doing the same activity, but keeping the same in the mathematical form. Okay, so that mathematical form comes like w1 x1 w plus w2 x2. Here we are taking only two inputs. We can take number of inputs, then we can call it sigma Wixi plus B. What is the bias we are adding? Bias is always in order to adjust that one, how much we are going to get. Okay, we know already answer, then we try to bring it a formula. So in order to get that formula, we'll try to add some constant. We can call it a constant. So that is how this neural network is developed. So this is called single layer. It doesn't have any extra layers. It whatever you have these inputs, and then we are doing some summation and adding little bias to get the desired output. So this is the starting of the things. If at all you are not getting anything in the neural network concept anytime in future, okay, you went ahead too far from this place to like learn so many things, but again, okay, basically how it is working, from this only you need to build the next level understanding. Okay, if you are not understanding this, you get stop here only, don't go anywhere. So you try to get what is happening with the perceptron or single layer neural network. Okay, this is this is how it is starts. Okay, hope everybody is clear with this concept. Okay, now we'll go to the next level. So now what we added from the previous level perceptron with one more keyword is the activation function. So this activation function generally comes with the what you call it, generally what is the activation function in generally, if you think, just one, in generally that activation function comes with the, you want to activate certain outputs and inputs based on the some what you call it, um, uh, you need some triggering point, like if you are getting some the values some 0 to 10, you want to correct them between 0 to 1. So here you are trying to scale between the 0 to 1 only. So if somebody is if you are attending any interview or if you are attending any of the event or something, okay, what is your understanding of the particular subject at the scale of 0 to 1 or 0 to 5? See, even nowadays I think all of you might be using the what you call some apps, right? So in the apps they are rating that 1 to 5, which is 5 is the highest, 1 is the lowest, right? This way we can have the what you call some scaling. So this activation function actually helps whether we want to like binary. Okay, 0 to 1, finally you need to tell whether the picture is correct or not, or particular image is either car or bike, or some particular image is a three-wheeler or four-wheeler, or sometimes whether it's apple or orange. So we need to, whatever we are understanding we have, that should be divided between the two inputs or two outputs or three outputs or thing. So this activation function actually helps that, see, you are doing the summation of all these things and adding some weight and bias and all these things, and if you apply the next level at activation function, it will decide the between two or three or n number of things. So in that process there are actually mathematics provides some binary like sigmoid activation function, tan hyperbolic a rectified linear unit. So like we can have many what you call activation functions are available, and that whichever is applicable based on your problem, whichever the problem you are going to solve, right, you can pick that. Okay, so this you will learn. Mostly all the people will use the sigmoid or tan h and rail, these things are generally used. Yeah, based on that how we are program, how you are developing your program, right, from there we can go. Okay. Okay, then I will move to the next one. Okay, so whatever you understood is a single layer, right? The single layer is very much clear to all of you, right? Single layer is having this much. And then when we go with the multiple layers, so multiple inputs, and internally you want to process more and more. Okay, whatever the value, when you sum this one, you are getting something. When you sum with this one, you are getting something. When sum with this one, you are getting. So you want to see all the combinations based on the different inputs we have, and from there we want to make the next level decision. You don't want to lose out certain things because the what is coming, this combination that comes. So all the permutations and combinations of the nodes from the input nodes, right, input level, you want to bring out and make a layer. So whatever from the perceptron we have input layer, and we are just adding the weights and then adding some bias. This first one is some bias and constant, and then activation function. So this is the single layer or perceptron understanding. When you go to the artificial next level is a multi-layer, you can call it the multi-layer. In that you will add the more number of the nodes, those called, that is a hidden layer. So always this input layer and output layer is constant, but these hidden layers can be vary, like based on the problem you are choosing, what problem you want to solve. Okay, so this is the very big scope of the artificial network. Here, when you are training from here to there, when you are having large data and training it, and then when you are moving around, right, you can take certain, like there is optimization, lot of optimization techniques are there. You can take certain layers, so you can remove certain connections, or you can, whenever this output is not coming properly, you can stop your training, or you can remove some inputs, or like that is called hyperparameter tuning. Okay, so the tuning part comes very later point, but first of all you need to understand how you build a neural network with a given problem. Okay, so we'll go to the next okay, and this much you understand now, because I don't want you bump with more and more information with this neural network. This much is enough to the, like to understand the basics on this. Okay, we will come back again this topic after the we will finish the finishing the convolution neural network. Okay, so I will pause a little one little time. So what is the, like you understood, like what are the keywords you can tell anybody, like what are the keywords you can think of, like from the so far understanding, right, in the artificial neural network? Okay. Anyways, I think people are little away from the mic and also. Anyway, don't, no problem. So then we'll say this neurons, layers, weights and biases and activation functions and all. I think you got right what it is I'm saying here. Okay. There is one more thing, that back propagation, feed forward. That is one thing I will cover in this topic. Okay. So whenever you are trying to call it, okay, you are trying to get something, like we'll take the this as an input. Okay, for this there are multiple layers of network is there, and we have some weights and all. So when you initially you are training a model using this, okay, or this are fully connected layer, like there are multiple hidden layers and all. So you give this x1 input, but x1 is not going to change, or means based on the problem it will change. For this model, when you are try to apply some w1, and then you do summation, and you did you whether you use activation function or not, assume a case you are using in this case, and then you are getting some output. So while training a model, you will check that this output is there or not, like whether the desired, like you will test with the known inputs, and some you will apply some weight, and then you expect some output. Like if that is not coming, okay, today what is that, today you applied some 10 rupees as input, and 10 rupees you apply given, and then you try to purchase something. Okay, okay, so I think you are all seeing the full screen here. Okay, right. So so whenever we are doing the back propagation, this back propagation, you try to adjust the weights based on the output you get, this, as you know. And once you are, then when the output is very, like whatever the error condition is very minimal, then you will assume, okay, this is the model I am going to take. So what is the model here? This x1, x2, x3 and all in future going to vary for the new, any new experiments and all. But this w0, w1, w2, w3 and all these things are actually weights, you understand, you will get. And these are the weights, and this is the function, input function, and then the activation function. Here I am using the summation. I may use different also. Don't stick to only this one. But for the explanation purpose, I am using this as a things. I can use different activation functions. I may use different, but this, when you are running the, when you are creating the model, or when you are creating a model and initial level, when you are running it, you will get the what are the weights, and what are the function you are using, what are the activation function you are using, what are the input function and activation function. This is how neural network is built. Okay, okay, now we'll go to the this part, how it is here. Also the weights will be there for each layer, how many layers you used, how many hidden layers you used, how many input layers. The input is one input is single layer only, but how many input nodes you used, and how much bias you put in the place, and how many like at each hidden layer or each layer inside, right? This what is the weight is attached to it, or how much weight it is coming, right? So through the feed forward, forward propagation and backward propagation or back propagation, right? You will understand how it is really built. So whenever the error is minimal, okay, error is minimal when the known inputs, later you will give the what are the new inputs in the same direction which you are giving, and they should work. So this is how the it remembers that one. So in a way how brain is processing our input data and then processing and something, right? So certain things we remember more, or because this is having more memory or more traction in that particular neuron and all. Okay, so that is how we are creating the same brain kind of network with using the artificial way. So that's how it is called the artificial neural network. Okay, hope you understood what is happening with the artificial neural network. Okay, this is the one of the key ingredient of the current nowadays whatever we are seeking speaking about artificial intelligence or AI, and this everywhere the world is buzz about it, right? So robots are coming and they're doing something and all, right? The robo are on the way. Actually there are many places they have in the place, and they use internally this kind of techniques to remember certain thing, to take some decision, to do something and all. Okay, we'll go to the next slide now. Okay, okay, now it comes to the convolutional neural network. In the place of convolutional neural network, it is a little higher side of the, it also uses the artificial neural network concepts, but it is again further level. Okay, so whatever the input it takes in the like image form, that image is taken, is a convolution plus relu what I told is one of the activation function, and then comes the pooling, and then comes the convolution plus relu pooling. So this feature, this is called feature learning. It will understand what is the data we have. See, initial very beginning slide we discussed about the various kind of data forms in that images, flat files, csv, db, and all those things are there, no? So inside that we are checking taking this image. This CNN very well works for the images. Okay, when we want to decide like the robo or whatever you are calling it, a machine has to recognize between the car and bus and bike, or cat or dog, like these are like whether the person is the same person or not, like it is me Sri Krishna or it's somebody else, or the Raju sir or somebody else, Silpa madam, like anybody, right? So we can take it has to remember, right? So it will understand the features of the face features, hair, and all that, right? See, generally it will record that one and it will try to tell that. So images, generally it will work on the images. So before going that we need to build a model. Once the model is built, then only it will the image image, whatever the image or photographs. I think nowadays we are all using social media, right? So in the Google photos or somewhere it will, once one image you give, it will recognize, and all other images it will tag. Even Facebook also having that thing. So they're all using this kind of algorithms inside that. Okay, so convolution here, when we'll go to the convolution means we are taking a data and we are making its convolution generally we'll try to wrapping it. Okay, in a like wired manner, and it will take the particular piece of the input first, like when you have big image, in that particular piece of the image we take, and then we'll try to apply this ReLU pooling and all. We'll discuss these components in next slide. So this fully connected layer, whatever I'm calling it, a fully connected layer, more or less looks like whatever we are saying the artificial neural network. But prior to that it will try to get this information in the prior to as inputs okay, this fully connected layer is nothing but are more or less very much similar to the ANN. Okay, but prior to that it is kind of pre-processing, like what are the inputs, like if you are giving as input like 1 or 2 3 and all, x1 x2 x3 and all, but those things are actually grasped or grabbed or like extracted from the images, and then it will be converted to like that, and there's a lot of processing is done to that image, then only it will get the the correspond here in this example, whatever I shown or pasted here, right? It is having this car, truck, van, bicycle, like it is just a image classification. It is doing with respect to various kind of vehicles or transport modes, or transport vehicles, whichever you have, okay, which is used for the commuting purpose. It can become something else also. Like today, the same algorithm can be trained with the other kind of images, and that model will behave to recognize which is the which image. Okay, like that we can build the so many other applications using this. Okay. Okay, so what I understood, what we understood, like input is coming as image. In that image, some sampling we are taking some sample, and then we are, and like that we have to apply whole image. The same whatever for the explanation purpose, we took simple sample from here, and then did this so and so and so on, right? This convolutional array loop pooling and all. We'll go in detail about little more detail about the convolution. Okay, so convolution layer is that what is the image size. Generally, it will when you convert into the image, right? When you can take the image, that is actually the form of the pixels. It is RGB. It is RGB is a red green blue combination. In that also each is a matrix. So 0 to 255, right? R1 0 to 255 is the range of the character, like pixel value, that pixel, and like that three combination. For red is one thing, and green is the other thing, and blue is the other thing. So this combination makes the image. So it will try to take that image and it will convert into the numbers, that numbers. So even color codes and all will have, I think you might have played with even general MS Paint or any other paint program. There will be some color codes, right? When you are trying to do something, it will give the some color combination of things. So again, internally it will convert into the number. So that number will give the what is. So when you go into the very lowest particle in an image, that is the pixel. Okay, that pixel will decide what it is. So we have to take some pixels, and then whatever we show no here for the understanding, you take one set, this matrix, how much matrix you are picking. So that matrix is the HWD, how much, like height, width, depth. So how many layers of the data we have. So even if you take only grayscale also we can have some, like how layers of the information one after other. That's why the color combination will get the nice like appealing or too much attractive colors we get because of that number of layers behind it. So basically RGB is the color. Again further we can have more layers also inside a picture. Okay, so now this image factor, and then we are taking that what is this size, like multiplies kernel, for kernel or filter matrix you can call it. What is this filter? Generally when you have some filter, like assume a case, there are, like you want to, which application, whether you want to blur the image. I think some people might have nowadays Snapchat, other things, right? They some applications we can blur the image, we can change the background, because that background is a different layer, that is stored as a different layer. Okay, because that is constant. And when you take the video, the background frames are different and front ground frames are different. So like that there are many evolutions or inventions happened in the image processing. When you study image processing, how really that is built, the structure is built in the each matrix, and how it is converted to the simplest form of the matrix in image, that you will understand. Okay, but for the sake of here, in the sake of CNN, we will take the little bit higher side. Okay, so this kernel is the, okay, I can call it 0 1 0 0 0 1 1 1 0 or something. There's a kernel, like, okay, this here he took the two this having total 4 by 4 matrix, right? In the 4 by 4 matrix I took the 2 by 2 as a filter, that I can call is a kernel. So this is called the convolutional layer. So this is the sequence of the CNN network. Okay, in the CNN network everywhere it happens. So when we have this information, this filter, you can call it filter instead of like kernel also same. So this kernel is a combination of zeros ones only. Okay, this zeros ones will pick from here, it will go around, like you assume a case, this is the complete image. First it will start here, and then it will move here, and then it move here, then move down, like that it will. That is what rotating in a fashion, like in the self resolve, like it will convolve in that. I think you know the literal meaning of the convolve, right? Convolution, right? So that convolution is happening with this filter on the image data, or in one image file or multiple image files. Okay, so then once it is going through what it is going through, it is again 0 1 0 or 1 0 0 or 1 1 1, that kind of filter only, it will not apply something else. Okay, then it will try to multiply those values as then we get this part. Okay, here. So here what is the combination of convolutional plus ReLU then pooling. This is what the feature learning, it will understand the what are the features of that image. Okay, so here once we get that one, this we'll apply the ReLU, like we got like this, and then the ReLU will do ReLU is a rectified linear unit another layer. Just simple case, you don't understand, if anything x below 0, then it will still take it as 0, like even 100 minus 100 is coming also, it is 100, just to 0 only. If it is going greater than some 20 30 200, it will give the 200. So this is the function, it is how written for this, that is a rectified linear unit. So rectified linear unit is the lower side, whichever the value coming, right, that value will remain as a 0, like even minus 1000 let it come, then that value will consider 0. This is called rectified. So this step is used in the combination of this feature learning, this plot. Okay, in the convolutional plus ReLU. Okay, ReLU is this one. And then we got some matrix after filtering, like it, whatever this kernel is going around, and then applied this ReLU whatever thing, and then we get the similar this kind of matrix. It may be this matrix may be having some other values earlier, and now it will reduce to this based on the, or it will convert, it will be in these features, which like if assume is what happens here, some values are positive, it will be aggravated, or same values, so if some value is negative, that will become 0 in general, right? When if it are multiplying with the zeros and ones and all, particular values will be nullified and particular values will hold. So the whatever the exact features like black pixels and no information pixels will be taken out, only whichever the pixels having some filled data, that only will come out, and that corresponding value will be here shown. So further, this one will be further contracted. It will be become reduced. Contraction means, right? So at this place we got 12, 28, 12. Okay, these are the values we are getting. Assume a case. So what will happen to them? There are multiple techniques, again max pooling, average pooling, different kind of poolings will be there. Okay, in this pooling, see 8, 20, 8, 12. This matrix will become, if you are using the max pooling technique, in this one which is higher value 20, and then when it this in this box which is higher value 30, and in this 112, and in this 37, sorry, okay, this in this max pooling 37. In average pooling we'll take all the value and submit and do average, and then make it this part, right? So 32 means 32 by 4 become 8, like that. So this average one. So depending upon which technique to be used, again this is kind of tuning parameter, like in initial level if you are getting not good results, we can reduce or make it higher, or different kind of pooling techniques also there. We will convert the original image like this is there, and then we'll convert to like this average pooling, then this becomes the input to the this part. Okay, this is called fully connected layer. So this fully connected layer will perform the further, it will further add the weights and then give the corresponding output. Okay, again we are coming back to the previously whichever we started with the from the perceptron, right? We are coming to the that part, but it is having the multiple hidden layers. So if particular combination of the model building is not working, model means again when we are training, right, new model should come, no? So that model, whenever we are building a model, this we need to either change or increase the hidden layers, or reducing the hidden layers, or laying particular this connections also we can remove. So lot of optimization possible in this case, and we need good computing power also to do all these things. Okay, okay, hope you are all clear with the CNN. Okay, so same thing, whichever if I want to declare or some, okay, in order to, here the convolutions will happen, like going from one step to other step, like that it will move around all the things, and then it will try to get this part, and then sampling part, and then convolution, subsampling, this part, like whatever the pooling and this will happen repeatedly. This feature learning, we need to get, if one set is not working, we need to do multiple times of this part. Okay, try it like that, we will get the whatever exact desired output. But in this, no, it will learn everything because it is going at the pixel level, and it will extract every bit of the information. Okay, and only thing is that we need to have the patience in order to get the corresponding model and the correct level of the computing for this. Okay. Okay, and the sequence of this and this is a fully connected layer at the end. Once this we have these inputs and all, right, so then this whatever the original input will become like this, and then we'll understand, we'll connect with the fully connected layer. After fully connect, for the regular ANN like thing, it will do. Okay. Okay, the differences between ANN versus CNN, I think you have seen, right? See, ANN will have this part input, multiple hidden layers, single hidden layer. If you take perceptron, even this also will, it will directly will add some weight and bias, and will throw out the output layer. But in convolution, it will go around the image. Like one, see, if you are starting this, whatever the matrix we are having this, no, it will start from here and go like this, and right, and then down, and then down, left, and then up, and then go to the next layer down, like this. It will convolute. So convolution is like this, no, like it will go inside that. So if you see many might have seen this circle, right, it will go inside. So like that, that image will be every bit of the information will be extracted and put it into this fully connected layer, and output will be whether it is a whichever the image we are trying to do. So in artificial neural network is a general and versatile. It is process data in one direction and suitable for this whatever the artificial neural, very much applicable for all kind of domains. But this is also applicable, but this mostly it will be in the image, specifically designed for the image recognition. A lot of image data, right? We need to get that pixel information, converting to the matrix, and then applying the matrix operations, that max pooling, soft max, like various kind of pooling techniques, and then applying some activation, and then like that, no, so there are multiple things are put it in place, the stocked up, decked up, to get the what to extract the exact features of that one. So CNN, once this one, next level of things we can take the whether, like whether we are using for the classification of the particular image and all. So most of the times images, whenever you are, whether we have to detect, like if you think mathematically, if you want to recognize particular image in one or other steps, you will classify them indirectly, right? So if a particular person is there or not, or a human or animal, or building, structure, or lake, like that, no, so indirectly you are doing classification, you are telling it openly, okay, this is a building, this is a lake, this is a man, a human, this is an animal. But indirectly you are comparing with others, and you are classifying them, right? That image recognition is very much possible, like this is designed for that, CNN is designed for that. So it will detect the features and weight share. These are all the main differences and all. But this requires good amount of data in order to recognize or do particularly which is what and all that features and all, right? It will compare if you are giving multiple flower images and all, it will all categorize all are flowers only, like, or if some trees coming, some other kind of things are coming. So that is where it do the difference between the, like, I think hope you are clear with the concepts between the NN and CNN, right? Okay, so we are anyways, I think we are close to 11. So students, so I open this house to questions.
Hello, sir.
Yeah, hi.
One student want to ask one question.
Yeah, please.
Sir, can neural network language processing use ANN?
Can neural network?
Can natural language processing use ANN?
Yeah, yes. That is text data, right? That is very much applicable to the text. Actually, original artificial neural network is used for the text, image, and other kind of data, voice also, even it can do voice also. But CNN is for specially designed for the CNN convolutional images.
Sir, how to decide number of hidden layers in one neural network?
um, See, it depends upon the based on the data, or whatever the number of what you call, what is your problem definition, that's where it starts. Okay, So whenever you have the hidden layers, like there are various frameworks are built. Like if you are using the uh, uh, using the what you call some data processing or something, okay, and if you have the whatever the number of times it is going the back propagation and forward propagation and your computation power, whatever your machine is having, how much computation power and all, right, it all depends, right? It is not the single factor we can decide the number of hidden layers. So what is your problem statement and how much processing is required, and then the internally what is the computing power you are where you are doing, where during the cloud operation or locally and all. And see, these are all things matters. It's not a single point, like we cannot tell in a single way, like but there are already readily usable frameworks are there, like some Google Net, Alexa Net, Dense Net. There are many existing frameworks are there. So people take the cues from the like information from the existing framework, like that is industry is using those frameworks, okay. So there how many data layers are using, how many are using that is one way of one crack, like one hack we can take it from that, and people start experimenting their model training.
Sir, my another question is, so before we give the data to any ML model or for learning, so we go for some pre-processing like missing values, outliers. Uh, hello, sir?
Yeah.
So can we build the neural networks to perform the same instead of that is being carried out by a data scientist, sir?
Yeah. See, this is a this is one alternative method to build a model, okay. It will learn and remember the things in a better way actually compared to the
Can we
general
take
model.
the neural networks to learn like how to process the data, data cleaning techniques?
Data cleaning techniques, huh?
Yes, sir. Like pre-processing, as I told, missing values, outliers removal. Can
Yeah,
we learn the models to learn
but
that?
that is a but yeah, it is possible. But thing is that is actually you are using high computing work or high computing resources to the that small scale work.
Okay. Okay, sir.
See, neural networks with everything is possible. From the simple logic gates, logic or AND gate, logic gates will be there. No, you'll be learning in the very beginning of the course of your whatever, right? So that also is possible to build using the neural net. But thing is that whether you that much computation, model building, or whether required or not, we need to cross check. See, whenever there is a no way, like, but it will thoroughly check or thoroughly give the things. Everything is possible with the neural network. Yeah,
Okay, sir. Thank you, sir.
yeah.
Any other questions, students? Okay, sir. Thank you so much, sir.
Yeah, thank you.
So, from behalf of SPTCSC, we thank you for the valuable time session on the neural networks, sir. Thank you so much, sir.
Yeah, thank you, Shilpa. Thank you, Vardara sir.
I also thank Varada Raju sir for giving us this opportunity to the students to participate in the session. Thank you, sir.
Thank you, Sri Krishna, for giving a very valuable input.
Yeah,
Even neural network and data analysis is the basics for our artificial intelligence and machine learning.
yeah,
Okay, without huge data, nothing can be done
yeah,
because no learning can take place. Because
yes,
even a child to say flame will burn means he has to practice.
yes,
Then only it
yes,
will learn and then it will keep applying, isn't
yes,
it?
yes,
Same
yes,
thing is happens. So
yeah,
learning is the most important aspect of
yeah,
your CNN,
yes.
ACNN.
Yeah,
Okay.
yeah.
Thank you
And
very much.
yeah, thank you. And I will end then my one last sentence, okay? And whatever you are learning on the artificial intelligence or data science in this world or in this competitive world or at this age, right, it is like you are learning alphabets only, okay. It is like that is how the world is moving. So better learn more and more in this direction, and you will be definitely rewarded well, okay. Yeah, thank you all.
Thank you very much.
Bye.
Thank you, sir.